everyone, myself Dr. Amrita Jyoti, Professor CETL Department, ABES Engineering College. Today we will discuss the topic transactions in the blockchain. Suppose A sends some money to B, right? This is the one transaction created by the A, right? And after the transaction is created, it propagates in this distributed network. So the question is that it comes to the picture that how the transaction faster than the present system. Basically, in a distributed architecture, a transaction is transmitted from peer to peer. Peer to peer algorithm works in this way to propagate the transactions to one node to other nodes. So transmission of the transaction across the network, that across the network around 1 to 2 seconds, right? It will work just like peer to peer, based on it peer to peer method. We can understand by this that suppose node A, node in the network, finds the transactions. Kevin pays 5 coins to James, right? Node, this is the one transaction. Kevin pays 5 coins to James. Nodes A broadcast to the peer B and C in the network, right? B and C to the network. Now again, ABC checks the basic format of the transactions and forward the transactions to their peers. Like in the same way, transaction propagates rapidly across the network. So definitely it's a fast than that there is a no middleman. B sends to the transactions to their neighbor. In the same way, C sends this transaction to their neighbors. So peer to peer works in the net in distributed network to forward the transactions. So now the thing is validations. So who validate the transaction as there is a no central authority? That is a very crucial questions to come into the mind, that if there is a no central authority, that who will validate these transactions. So there are some special nodes in the network that verify the transactions, maintain the ledger. They called miners, right? So miners are the spatial nodes. We can say spatial nodes because they use their computing power to validate the transactions. And in the respect of this validate the transactions, they got some award or reward also. So that's why we call that is a spatial nodes. Every node, every node in the network be a spatial nodes to validate the transactions. Means every node has a full capability to validate the transactions, but some nodes don't take part in this race to validate the transactions. So we can say that that is a spatial nodes. So miners are spatial nodes that hold the copy of the ledger and verify the transactions happening in the network. We can understand this verification concept through this example. James James wallets, private key, James private key, and James public key. James wants to send some money to Kevin, right? James wants some 5 BTC, 5 bitcoins to Kevin. So James used their digital signature and send these transactions to the node. These transactions come to this node, right? And this digital signature. Okay, James wallet has James private key and James public key. James initiate a transaction. James wants to 5 BTC coin to Kevin. So James, this is the transaction, and James used his private key to encrypt this message. Just like we send a check to my friend with my signature. In the same way, uh, James digitally signature like his private key using his private key and using as digital signature, and that create this message, and this message is come to this node, and this node using the peer-to-peer method, this node transaction is come to that node, that node is sent to their nearby node. In the same way, this transaction is propagated within a um, this transaction come to the all nodes. This is the digital signature method, and James public key. Every node in the network has a James public key, right? This is the asymmetric key cryptographic concept that something is encrypted using the private key, and that is the decrypted by it's a public key. So digital signature plus James public key, that every node get that message James Kevin 5 BTC. So transaction message is authenticated using the James public key. Now the concept is storage. Once the transaction is verified, it is stored in a shared ledger across the network. So understand the concept of this, that this is the same ledger. James have this amount of money. James sends Kevin to this dollar. Kevin sends some amount to Paul, and Paul sends some amount to Robert. All right. So these, there is an a one ledger, one same ledger that every node has in the network. There is a no central ledger. There is a no one central ledger, just like in a bank, that every person, this is the James, he's Robert, Kevin, Paul, everybody has same ledger, right? This is the concept of the distributed ledger in the blockchain, that every node in the network has the same ledger. There is a no any central ledger, right? So ordering of the transactions. Transactions are passed from node to node. So there is a no guarantee that the order in which you receive them represent the order in which they are already created. To agree upon the order of the transaction is a challenge in the decentralized system, or we can say this is the one challenge in the blockchain system to ordering of the transactions. Therefore, the cryptocurrency system order transaction by placing them in a group is called the blocks and then linking them in a chain. We can understand by these things that suppose this is the A node, right? And these are the different nodes in the system B and C, and other are also in the network. B is created a transactions, right? Suppose this name is a B1 to understand the concept. C is created a transaction C1 after the B1. But after the peer, but after the peer-to-peer algorithm, A received the transaction C1, right? Then after some time, after the C1, A get the transactions B1. So order is different from that as they are created, right? So the order of the receiving by a node and is different from the order they are created. This is a challenge in the cryptographic system, and therefore we in the blockchain um, we not linking the transactions. We link the block, and the block has some transactions. So this is the unconfirmed transactions pool. Firstly, this is a place where the all unconfirmed transactions means they are just initiated the transactions by Elisa. Lisa sends some 7 BTC to Sandra. Mary sends 10 BTC to John. James sends 5 BTC. These are the untransactions, means they are just initiated. They are not confirmed, right? So these all unconfirmed transactions create a pool in that area, all right? some nodes some nodes pick these transactions and create a block on that transactions. Suppose node, this node A create a block to the create a block of these transactions. So node A create a block, and in this block there are all transactions. These transactions are firstly they are in a this unconfirmed transactions pool. Node A pick these all transactions and create a block. This is the block ID, and this is the hash of the previous block. So already this blockchain exists. This is the block number 145, 146, 147, 148. So definitely miner will try to create a block number 149. So different nodes, different miners will try to create this block, right? And they will they want that their block will be selected. So this is the block number 149, and use the hash of the previous block. We can see that this is the hash of that this block hash is 8JJ40, right? This is the hash of the this block 145. So this block hash will used in the previous block hashing in the block number 146, right? In the same way, this is the hash of that block, and this same will work in this block. In the same way, we will use that block hash for JJ40. The miner will use that it works as in a previous hash in that block, right? So the miner will create this block and send to the all other nodes. Various miners are constructing blocks. There could be several options to choose from. How does the network decide which block should be the next in the chain? Very simple questions. There are number of miners A, B, C, right? So they are trying to create their blocks, and they want that their block will be selected. तो किसका block select होगा? Very simple answer that the block which will create, जो सबसे पहले create करेगा, उसी के ब्लॉक के सिलेक्ट होने की प्रोबेबिलिटी और चांसेस सबसे ज्यादा है. बट like new block. That block is proposed by Lisa, that block is proposed by Paul. So there can be a number of miners constructing a block. Those block will be chosen by the network. So proof of work is a piece of data which is difficult, costly, and time consuming to produce, but easy for others to verify to satisfy certain requirements. A part of Bitcoin solution is that each block must contain the answer to special maths problem. So proof of work, proof of work is just a mathematically problem, right? First, the person who will solve this issue, that blocks will be selected. So there are three components in this proof of work which help in achieving the proof of work solution. First is the nodes. Nodes is a random number. This value uh, is set so that the hash of the block will contain a run of leading zeros. The rest of the field may not be changed as they haven't defined. Hash basically a fixed length number which results in a large unchanged data when read. And transaction is the authentic transfer Bitcoin ownership collected and recorded in a blockchain. So, so we can understand the concept of the hash here. So this is the nonce. Nonce is the random number which helps to create a number of leading zero in the hash. Right. Basically, hash is a one way number. हर एक डाटा के लिए डिफरेंट हैश होता है. Suppose there is a number of this is the data. This is the hash for this data plus nonce number. So if I'm using this button mine, it means the nonce, a different nonce number will create that will be added with this data, and the number of leading zero will be created. Right. Mine 106148. This nonce number will add with this data, and leading zero will be created. So this is the concept of the proof of work. In the proof of work, we have to create a nonce number. That nonce number will add with the transactions, add with the block, and create a leading zeros hash. So this is a sample. This is just sample. There are a number of four zeros in the hash. So suppose okay. We can understand the concept of hash with the help of these tools. Suppose there is any data, right? And this is the SHA-256 hash. Hash is a one-way function. Suppose I'm just changing one dot in that data, the complete hash will be changed, right? And with the help of hash, we can't create the data. So this is the one-way function. So this is the concept of the nonce number. right? So nose is a random a number which add with the data and create a leading of zero of hash, right? Suppose this is our transactions, right? This is our transactions, and we have to we have to find the किसी नोड को माइनर बनने के लिए उसको उस नोड नंबर को फाइंड करना है जिसमें उसकी लीडिंग जो हैश में जो जीरोस आती हैं, राइट, वो क्रिएट कर सके। मींस टू क्रिएट अ लीडिंग जीरो द माइनर शुड माइनर विल हैव टू क्रिएट द नोड नंबर, right? And this nose number, and to find this nose number, it has to be a various used to the very computing high computing power, and will that miner will use their electricity to create this nose number, right? So yes, add 8013, add this nose number 8013 will add with this data and create the leading zeros. So this is the proof of work problem. Right? Suppose I'm just taking a different example. Suppose this is the transaction. This is the transaction information, right? Every data has a unique hash. For this transaction, the hash is this, right? But but miner have to create the a nose number. That nose number with will add with the data and create a leading zero. So this is the mining. I'm just press the mining button. So at number 5131, this 5131 at nose number will add with this data, it creating a 5 hashes, right? And to simply understand the concept of the blockchain, this is the block one, nose number, this is the data, this is the hash, and previous hash is a genesis block, that is the previous is only 0. Hash of this block is start with the 4 times 0 and then 1578. In the same way, next block has the previous hash and the block of hash. This is the block. So this is the concept of the transactions in the blockchain, proof of work, what is a nonce number. So thank you so much for watching this video.